here to talk to you guys. Can you hear me okay? It's not laggy or anything.
Yes, I can
It's
hear
okay.
you clearly. I guess everyone can hear you. If you can hear him, you can use a thumbs up or something and drop it down
Okay,
again.
sure. Yeah, just let me know if like my signal isn't great or anything. But yeah, pretty much plan for today is I want to talk to you guys about software engineering in industry. I think Mr. Mensa mentioned this in his intro, but doing CS in school is very different from working in software in industry, no matter where you are in the world. I definitely felt that when I was in college. So yeah, my goal today is just to give you an idea of what my job looks like and some things you should keep in mind if you're looking to go into software engineering in the industry. Um, uh, Mark, would you mind making me a presenter so I can share my screen? I have
Yes,
some
of course.
slides.
Just a sec.
Sure.
Please, you should be able to present now.
Yes, got it. Okay. All right. Can you guys see this? It should say, what is software engineering? Yeah. Am I sharing the right screen? Hopefully I'm
Yes,
not
you are.
sharing.
Yes, you are.
Okay. Okay, cool. So yeah, as I mentioned today, I'm going to talk about what software engineering in the industry looks like. So there's a bunch of things I want to cover today, which I kind of listed out here. And then, as Mark mentioned, we'll have some time for questions at the end. So I guess if you have any questions that come up, just kind of take note throughout my presentation, and then I will try my best to answer them at the end. So I'll start off with a little bit of a personal introduction about my background. Then I'll talk about software engineering at a pretty high level, which maybe is review for you guys. Then I want to talk about what I think are some big differences between working in the industry versus studying CS in school. Then I want to talk about like the software engineering workflow. So pretty much what my job looks like, what I do on like a day-to-day basis. Um, After that, I'll go over some variations within software engineering, like different types of roles within the field, because it's a very broad field. And finally, I'll end with some advice for you guys as college students. So yeah, let's go ahead and start with a bit of my personal background, and I'll try to go through this quickly. But oh, okay, so yeah, as I mentioned, my name is Kenny. I was born and raised in the Bay Area of California, so pretty close to San Francisco. I'm actually about an hour south of San Francisco. Grew up in the Silicon Valley of the Bay Area, so this is where like all the tech companies are. So it's pretty funny. I grew up here and I ended up back here working for Google, so it's like I never really left. My parents both immigrated to the US from China. They both were born in China, went to school in China, and they came to the US in their mid 20s for graduate school after college. So that's when they came to the US. And then I was born here, spent my whole life in America. And yeah, spent most of my life living in the Bay Area. So that's a little bit about my like early background. And then I guess a little bit about my CS background. So I started getting into computer science back in my high school years, but it wasn't really too formal. Basically, the first time I ever coded was I joined this web development competition in my freshman year of high school. So I was like 14 or 15. I joined this competition, and basically this contest had a prompt, and every team who joined the contest had to build a seat reservation system. So just some sort of system for users, fake users, obviously, to like look at seats and reserve potential seats, like a concert or something. So basically, I had to build this entire system, and I didn't know how to do anything. So in my freshman year of high school, I pretty much just went online and self-studied like HTML, CSS, JavaScript, and databases, pretty much whatever I needed to learn in order to build a functional website. So that was like my first step into CS. I kind of just learned everything from the internet, from like Googling stuff, and then threw together this website for this competition. After that, throughout high school, I continued to work on a lot of like web-related projects mostly. Some examples are I went to some hackathons and built projects there. I built a lot of websites for like clubs at my school and local businesses. And I also started a web development club at my high school. So I taught my like peers, at that point I was like a junior in high school, so I taught the younger students how to build their own websites. So this is all the kind of coding stuff that I did in high school. So yeah, that's where I got started. After graduating high school, I went to Columbia University in New York to study computer science, and that's where I really started to learn more of the fundamentals. I took a lot of CS classes like data structures, as well as a lot of courses in like application development and machine learning mostly. Um, and yeah, aside from taking classes in college, I also worked as a teaching assistant for several courses, including an introduction to Python course. Oh, I think my video disappeared. Oh, it doesn't matter. But yeah, I TA'd several courses, including an intro to Python course, a data structures course, and a user interface design course. And while I was in college, I also interned at Google for 2 summers. So 2 separate internships doing front end development. So I was working on a lot of web programming. I was in the ads department for those summers. Currently, I am back at Google working as a full-time software engineer. I've been here about a year. I'm working on the YouTube ads team, which is under Google Ads. Specifically, I work on the client infrastructure team, which is basically the team that's responsible for serving all the ads data. And I'll get into more detail about this later when I talk about what I do on a day-to-day basis. But in summary, basically what my team does is that there's a lot of different types of ads on different pages on YouTube, which hopefully you guys are all familiar with, but lots of different ads on all the different YouTube pages. And our job is to make sure that all these different types of ads are represented and served efficiently, because we need to do something different for each of them. So yeah, I'll get into more details about that later. Cool. So that's all I wanted to talk about myself. I guess anyone have any quick questions before we dive into like the main content of the presentation today? If not, we can also save them for the end.
I suggest we save them for the end. Yeah, so you can
Sounds
proceed.
good.
Yes.
Okay, cool. Okay, so the first thing I'll talk about today in terms of content is I just want to give a little overview of what software engineering is. Some of this stuff might sound very basic to you, but we'll go through this section quickly. So there's a lot of different definitions for software engineer, but in general, I think there's someone who designs, builds, tests, and maintains computer software. And I wanted to emphasize all these words because it's a lot more than just coding. Designing, testing, and maintaining software is just as important to the job as like just coding something and sending it out there. And I'll get more into examples about this later. But in general, you can think of a software engineer as someone who applies computer science knowledge to real world applications. So for you guys, you're basically going to take a lot of the things you learn in school and then apply it to real world companies in one way or another. And because software is needed in pretty much almost every industry these days, someone has to be there to build it, like no matter what industry you're in. So for example, if you're at a tech startup, like, I don't know, Twitter when it first founded or YouTube back in the day, you need a software engineer there to actually build the product. And aside from just making the platform, like building YouTube, they also need software engineers to improve the system, to fix issues that come up and add new features. Otherwise, if you only have people code new stuff, you're never going to be able to like fix things that happen. It's just not a very robust system. So software engineers are responsible for all of that. And examples of other fields that need software engineering besides like computer applications are maybe banking, like security or cybersecurity at banks, software for cars, even like retail stores or delivery need software engineers to build systems to track their inventory. So pretty much any field that you can think of that has technology involved needs software engineers one way or another. And because that's so broad, that's why software engineering is such like, I guess, a growing career field right now. But yeah, main thing I really want to emphasize here is just that being a software engineer requires a lot more work than just coding. A lot of time is spent designing or planning how to build new features, and you have to coordinate with other teams. Like as a software engineer, I have to talk to not only other software engineers, but maybe data scientists, user interface designers who will create like what I'm making, like how it looks. might have to talk to the product team who are actually deciding what I should be building, or maybe I have to talk to the legal team because there may be legal ramifications from like things I do, especially since I'm on the ads team. There's a lot of laws around like who can see ads, what you need to do with them. So you have to talk to a lot of different teams besides just other software engineers. Aside from designing and coding, you also have to optimize and test software. Obviously, you can't just write something and hope it works. You have to make sure that it works through writing tests. And you also have to maintain these systems because new errors come up all the time, especially when you're working at the scale that Google's at. There's millions and billions of users around the world. If there's a way to break our software, they will find it and we have to fix it. So we have to pay attention to that. So yeah, all of this goes into the work of a software engineer. And last thing I want to talk about on this slide is just that computer science knowledge that you learn in school is very critical. Even if sometimes it feels, I remember when I was in college and I was learning CS, sometimes I would take a class and be like, all right, this feels kind of random. I don't know why I'm learning this stuff. Sometimes it's true, but a lot of the stuff you learn in school becomes very important in the field because, as I mentioned, as a software engineer, you have to work with so many different types of like technology. You don't really know what you need to know. So everything you learn in school will come in handy one way or another when you're developing software. But yeah, just remember that without software engineers, a lot of products that exist today would be nothing more than ideas because we're the ones who are creating these things and making them happen. So that was a lot of words. I'm going to talk a little bit more now about what the differences are between school and working in industry. And this is mostly from my personal experience. So maybe it won't all apply to you guys, but hopefully some of it applies. So here are some of the differences that I kind of came up with. Let's talk about what school is like first. So from my time in school, I've always felt that in school you work on very well-defined and isolated problems. So like when you're working on a homework assignment, it's usually related to the lesson that you just learned or the lecture that you just listened to. And you know that for a given class, the homework assignments will only be related to topics for that class usually. So it's very easy to map what you learn to what you need in order to solve or build an assignment. So it's very isolated. In school, there's also very clear solutions and timelines. For a given assignment, there's a given set of solutions usually, and your goal is just to find those solutions. And there's also a deadline, like your homework is due at a certain time. In school, if you're working on team projects sometimes, usually these will be pretty small teams. You work with maybe 3 or 4 people and you work together to finish some problems or code up a little project or something. When you're working on these projects in school, you often usually also write all your code from a fresh code base, meaning you don't have to bother with anyone else's code. You just write your own code, start from scratch, and then submit that. So that's kind of unique to school, I would say. And the last thing that's kind of unique about school is I feel like just because you take a lot of different types of classes, you kind of are exposed to a very diverse breadth of topics. You will take some classes in school that you won't use in industry. For example, I took a lot of machine learning courses in school, but I don't really use any machine learning for my current job. But that doesn't mean those classes are not worth taking because school is a great opportunity to figure out what subfields in CS you're interested in. You don't really get that opportunity in industry as much. So definitely take advantage of that. So all of these are pretty different from how being in a software engineer in a real company is actually like. First of all, you don't have homework at these companies, you have projects. And a lot of times these projects, the requirements are very complicated and vague. Like sometimes, I'll get into an example about this later, but often your product manager will just be like, hey, we need to create a type of ad to increase user engagement by 50%. And that's all they say to you. And as someone on the tech team, I might be like, okay, well, that means absolutely nothing to me. I don't know like what I'm supposed to do. Your job as a software engineer is to investigate that and figure out like what questions to ask. And that's very different from school where they ask you the question and you find the solution. In industry, you figure out what questions you need to ask and you figure out what solutions you need to come up with. Because of that, because it's a lot more vague, there's also not really a clear solution or timeline. There's a lot of different designs or solutions that are possible for a given problem. So your job as a software engineer is to consider all these different possibilities, present them in a very organized way. Like here's option one, here's option two, here's option three, and getting people's opinions, like other people on your team, your managers. And then you work together to decide what to go with. And this obviously, as you can tell, is pretty different from doing homework in school. The other thing that's different is there's not always a finished state when you're working on projects for work. A lot of times you can get something to a good enough state, but there's always more you can do to make it more complete. Other things that are different in industry are that you are going to work with a lot more people than just like 3 or 4 people. You have to work with people on different teams, as I mentioned before. You'll also be writing code as part of a code base that already exists. Like at Google, I'm never writing code completely from scratch. There's always some code that someone else has written that I can use, and that's very different from school, where you kind of always start from scratch. And because other people are reading your code as well, you have to learn good practices by working in industry. You have to learn to write code that is easy for other people to read. You have to write tests that make it easy for other people to ensure that your code works. Since you're not the only one looking at your code, you have to write very disciplined and clean code. And that's something that I learned a lot more after starting work that I didn't really always think about in school. Like I think in school, sometimes I would just write whatever I wanted just to have something that satisfied the solution, but I didn't really care if the code was like clean or anything. You learn a lot of good practices by being in industry. So yeah, those are just some differences between working in school and working in the workplace. And with that, this is probably the main section that I want to talk about today. Basically, I'm going to be talking about what my typical workflow looks like. So from the time that I get assigned a project to when I launch that project, what are all the steps in between that? And hopefully it's okay if like some of it is difficult to follow, but the main thing I want to emphasize is there's a lot more steps involved than just coding. To be specific, here are all the steps that I kind of think I go through at work. And I'll go through these in more detail. But first, there's some product decision that's made. So someone on the product team or UI team is going to come to the tech team and be like, hey, we have this idea for this new feature that we want for our users. Can you build it? And usually at this point, it's pretty vague. So the next step is for me as an engineer to gather requirements and understand what exactly it is that we're trying to build. After I have an idea of what we want to build, I have to draft up an engineering design. So usually I write a doc to outline all the different ideas or proposals I have. After that is when I can actually start coding. And then once I finish coding, I have to test the code, and there's various ways to do that. And after I test and launch the code, I still have to pay attention to it to make sure that there aren't any new crashes. I have to maintain the system and improve it if there are new ways to do that. So yeah, let's go through these step by step. And I want to use a real example of something that I've worked on and how each of these steps factored into that after I take a sip of water. All right. So the example I'm going to talk about today is this specific type of ad on YouTube. It's called a discovery ad on YouTube. So this is a feature that I'm actually still working on right now, almost done. But it does already exist on YouTube. Basically, it's a specific type of ad that can occur on different pages on YouTube. In this first picture, this is the home page. So what will happen is when you load your homepage on YouTube, there's a bunch of recommended videos. In between recommended videos, sometimes there will be an ad video, and we will call these a discovery ad because the point is to let users discover a new product that maybe they didn't know about before. What happens is when you click on this ad, this video ad, it'll take you to the actual video. So it'll pull up the ad video like a normal YouTube video. And then below the video, there'll be some ad information. So this type of ad can appear on the search page as well. Like if you search for something on YouTube, it'll show you all the search results, but at the top, there could also be a discovery ad. That'll like be the first entry in the search page. And this also appears on what we call the watch next page. So on this page, this is the page where you're watching any YouTube video. When you scroll down below that video, there's usually a feed of like recommended similar videos, related videos. In that list of videos, we could also put a discovery ad, and that links you to the ad video. So this is a feature that I worked on. And now I'll go through each of the steps of like how I worked on this and things I had to do at each step. So yeah, it's totally okay if you don't fully understand what this product or this ad does. I'm just using it as an example. Okay, so the first step, as I mentioned, is that some product decision is made. So at some point, a product or feature idea has to be decided, and it's usually decided by higher ups, often product managers. They'll look at the users and be like, okay, we see that the users are using YouTube in this way. Let's think of a new type of ad to show to these users. But at this point, the technical details aren't finalized because they're product managers. They don't know exactly how to build it. All they know is what they want and what the users, what they want to show to the users. So they'll come to the software engineers with this product idea and be like, hey, this is something that we've decided we want, a new feature idea. Make it happen, or can you make it happen? So in, I guess the example I just gave, the product team decided that they wanted to launch discovery ads on YouTube. And they came to us, and our job was to figure out all the technical details about how to make this ad work and how to make it work efficiently. So the screenshot here is a real example of my YouTube app actually on my personal phone, and a discovery ad that appeared on my homepage. So yeah, clicking on that would take you to the ad video. Cool. So after the product decision is made, which is probably the part where as an engineer, you don't have to do anything. The first thing that as an engineer I have to do is I have to start to gather requirements. And the point of this is just to understand what's being built. I have to investigate all the technical needs that are required to implement this feature. Along with that, I have to understand what system this affects. And to do that, usually I'll look through the code base to see how is the code for the current YouTube page written, where will I have to insert my code, and what parts of the code will it affect. And I can also learn from similar projects. There's lots of different other types of ads within YouTube, so there's probably some similarities between those and the discovery ads that I need to implement. So I will usually look at those projects and try to learn from them. So in the case of my discovery ads example, during this phase, up to this point, I didn't really know anything. Could someone mute their mic? I think I hear some background noise.
Sorry about that, guys. Please make sure you are muted. Don't interrupt us. Please make sure you are muted. We'll give you an opportunity to ask your questions. When you join, first make sure you are muted, please. Thank you. Kenny, I think you can continue.
Yeah, I think that's good. But yeah, so at this point, all I knew was they wanted us to implement this type of ad, but I didn't know anything about it. So one thing that I kind of investigated here is how the YouTube calls work. So for example, on each page of YouTube, if you're on the home page or the search page or the watch page, each page makes a different RPC call. So what happens is when you load the home page will call some API function like get home or something. And that function gets all the data for you. So it'll get all the videos that they want to recommend to you on the home page. On the search page, there's a separate RPC call for the get search results. And then same on the watch or watch next page. So after I learned that, I kind of understood that whatever code I wrote had to fit into all of those. So within the get home call, I needed some way to return a discovery ad. Then within the get search call, I also needed some way to return a discovery ad. That's something the product managers don't tell me because they don't know that themselves, but that's something I had to investigate myself. The other thing I had to kind of understand was how exactly these ads behave. Specifically, even though these ads appear on different pages, if you click on a discovery ad, no matter what page you're on, the same thing will happen. And that is, it will pull up an ad video. That's the bottom screenshot here. And then you can watch that ad video. And on that ad video page, there's something called an ad companion, which is this little banner right under the video. That just goes along with the video, and it's just extra information about the ad, and then a button you can click to like go to the website or install the app or something. So these are all details that I didn't know at the beginning, but I had to investigate myself in order to have enough knowledge to start coding. Like there's no way you can start coding just from the product manager's description. Anyways, after I kind of had an idea of what the like technical requirements and how things were structured look like, it was time to write a proposal or my engineering design. So it's not enough for me just to understand how things work. I have to convince other people that the approach I want to go with is the right approach. So usually what will happen is I'll come up with a detailed document or outline of how the code will look. And there'll be a lot of writing, a lot of paragraphs about why I decided to structure it this way, different options we have for structuring it different ways. Since there's so many possibilities, it's really important to discuss the pros and cons. And usually my manager will look at this and give me feedback on why we should or shouldn't do things a certain way. I also probably need to get approval from different teams since this affects different systems. It affects the home page, the search page, and the watch page. So I need to check with people who work on those teams to make sure this won't get in the way of things that they're working on. After I have a design that's finalized, then I can decide how to split up the work between me and my teammates and how to prioritize that work, because some of the work I would need to do before others. So going back to my example, during this phase, one thing I thought about is that, or I guess my team thought about, is that we could write code for each of these pages separately. Like we could have some function within the get home call to get the discovery ad for the home page, and then a separate call to get the discovery ad for the search page, and then a separate one for the watch page. But we thought that since the ad looks the same on all the pages and the only difference is what page it's on, it would be a better idea to have a single unified library handle all the ads rendering to make the shared code, to make sharing the code easy. So what would happen is no matter if the call is get home or get search, no matter what page you're on, all of them will call the same ads library, and that ads library will return the same ad, so the same discovery ad. And this is a really good engineering design decision because it makes the code very easy to share. So instead of writing the same code 3 times or similar code 3 times, we just have it in one place. So it unifies everything. So yeah, that was a design decision that we had to think about for a long time. And it was really important that we decided on that and agreed on that together before anyone started coding, because otherwise someone would have started, then someone would have had problems with that, and then we wouldn't have really got anywhere. So that example is, I guess, an example for why it's important to come up with engineering design before you start coding. After a design is finalized, that's the point where you can actually start coding. And I always say, I like to think that coding only takes up probably 20 to 25% of my time at work, because a lot more of the time is spent designing and convincing other people why my design is good, and then later on testing my code. But coding is actually not that hard because all you need to do is take what you've designed and translate it into code. But at that point, you already know exactly what you need to write, how everything works. Everything's already planned out. You just need to translate it from text to code. I think another important thing to realize is that coding and designing is a very iterative process. And that sometimes when you start coding, you'll find out that some parts block other parts, or some parts are more complicated than you realized at the beginning. And at that point, you'll have to go back, submit a more detailed design for that specific portion, get approval on that, and then go back to code. So it's kind of like a cycle. And you don't really know like how many times you have to go through the cycle, but it's very natural. And then the other thing that I typically do, or I guess pretty much everyone does as a software engineer, is that you have to review other people's code, because you work on teams and your code affects other people and other people's code affects you. So you often review other people's code before they submit it to the system. So one example of something that I realized after I started coding, and then I had to go back to submit more design decisions for, is I think I talked about this companion ad. So this appears below the ad video, and it's just extra data about the ad for the user to like click on stuff and do whatever. One thing I didn't realize is that there's actually 2 different versions of the companion ad. There's an action companion and an app companion. So an action companion is when the ad is associated with some external website. So the user should be able to click on the button and then go to the website. That's actually different from an app companion, which links to an app. So that when the user clicks on the button, it leads them to install the app in like the Google Play Store or the Apple Store. And as you can see, the companion ad's a little different. In the subtitle next to the ad logo, the action companion has the website URL, but the app companion has the app's rating and the price. And obviously the rating and price doesn't apply to a website. That's specific to an app. So I didn't think about that when I first designed this project. And it was only after I started coding that I realized, oh shoot, like I forgot to consider this. So at that point, I had to go back and propose a new design. So this chunk of code down here, it's oversimplified, but gets the point across. We have some structure that represents these companion ads. So there's like a title for the ad, an icon, some text for the button. So these fields already existed. I had to propose adding some type of field to distinguish between app and action, because in the code that I write, I needed to know whether it was an app or an action in order to make certain things work. So I had to go back, propose adding this to the representation of this ad, get approval for it, and then after that, I could go back and progress with my code. So that's an example of why this process is iterative. Okay, only 2 more sections. After all the coding is complete, you'll usually start testing. Well, actually, you probably test while you're coding, but you have to like test all the code that you write. And the whole point of this section is to try to break what you wrote. I think testing is actually one of the things that was most new to me coming out of school, because in school, I feel like testing is just seeing if your project worked and seeing if it satisfies the solution. But in work, you have to think about all the different ways that someone could break your code, have to test all these different, what we call edge cases. And there's a couple different ways to do that. You could write a unit test, which usually tests one specific type of code or one specific chunk of code in the system, or an end-to-end test, which tests like the entire flow. So it's just a bigger test. Another way we test code is we would sometimes run live traffic experiments and then analyze the metrics. So what I might do is if my feature is complete, I would run an experiment where maybe 0.1% of all users around the world see my code in the real app. And then based on that 0.1%, I can look at the metrics and it'll tell me, okay, for this 0.1%, we had like 20% crash rate, a lot of stuff broke. If that's the case, then I can turn off the experiment and I know that there's some issues with the code that I wrote because the small amount of people who used it had issues with it. That's a lot better than sending your code to 100% of all users and then having a crash for 100% of all users. So when we submit code, we usually try to run experiments and then slowly ramp it up to 1%, 2%, 5%, etc. So yeah, really quick, an example of a test that I might write. Pretty simple. All I might do is come up with some fake test data for a companion ad, like something like this. And then I would write a test so that it creates a sample ad from that test data. And then I can just look at that sample ad to see if it works as expected. Usually this is a good way to, sometimes maybe I'll see like the button text is missing, so that means something's wrong with that code. This is an example of a very simple unit test I will write to make sure that our code works. Because if it breaks for me, it's definitely going to break for users if we launch it. Cool. So after, if all the tests pass and we launched the product to like 50 or 100% of all users, after that, our last step is to maintain and improve the system. And there's a couple different things that we have to do. One is that we have to monitor the usage data and errors. This is what I mentioned before. We'll look at the metrics, see what the crash rate is, see if there's any weird errors. And if things come up, we have to look into it, investigate, and try to fix them, because there usually are unexpected bugs that come up. There's also something called on-call at most big tech companies. Usually what happens is a given team, the team members on that team will take turns being on call. And what that means is if there's some major error, we'll get a phone call about it from the system, and we have to respond to it and look into that issue like within 30 minutes. So during the week that you're on call, you have to be ready to pick up your phone 24/7, even if it's at like 2 a.m. middle of the night. If you get paged on your phone and you're on call, you have to look into the issue and figure out like where it's coming from. And the goal is just to investigate it and tell people on the team that there is an issue, not necessarily to fix it. So that's just another way that we maintain the system and catch errors as soon as they come up. And obviously the last thing is that we want to make improvements to the system. I have a pretty silly example here. I did a partial launch of this discovery ads, I think maybe to like 1 or 2% of users. And one issue we found is that the little install button on the right, this is what I launched, it was actually slightly smaller than what the UI designers wanted it. They wanted it to be a little thicker, but I accidentally launched it at the smaller size. And no one really caught it during testing because it's a little tough to notice. So what I had to do is after we caught this, I had to go back and submit a fix for it. But since it was already live to users, I had to run an experiment to make sure that changing the button by this size wouldn't cause any weird breakages. Like I didn't think it would, but just to be safe. So I had to go through a whole process just to make the button a little bigger and to make sure that the click rates didn't drop down or whatever. But yeah, that's just an example of improvements that you have to make after code is already submitted. So yeah, that's all I had to talk about for this section. I kind of blabbered a lot about stuff that I've worked on, but if there's one thing that you should take away from this section, it's that working as a software engineer is a lot more of an iterative process than just coding for like a homework assignment or something. So yeah, that's something that takes a while to learn when you get into industry, but I think everyone who comes from school to industry kind of learns these same things, and you learn a lot of valuable skills from this process. But yeah, hopefully that gave a clearer picture as to like what the job is like. Okay, now that that's done, I have only a couple slides left. These should be pretty quick. In this section, I wanted to talk about different variations of software engineering that maybe you didn't think about before. So I think a lot of times while you're in school, you have this idea that software engineering is what you want to do coming from computer science, but you don't really know what the different options are because it's such a broad field. And just knowing that you want to be a software engineer is still pretty vague. Like there's a lot of things to decide beneath that. So here I listed out some things that you might want to consider. First and most importantly is the type of software engineering that you want to do. And this only scratches the surface, but you could be a front-end engineer who works mostly on like how the website appears to the user. So this will be a lot of like JavaScript, HTML, CSS. You could be a back-end engineer, which is like what I do, responsible for writing data pipelines and infrastructure. There are mobile engineers who create mobile applications, game or graphics engineers who maybe render graphics for video games, machine learning or data science engineers who work with large amounts of data, which is very different from like an application-based engineer. DevOps, whose job is more to build tools for other engineers and people in the company to use. QA, whose job is pretty much just to test and break things to make sure that it's quality assurance, to make sure that the quality of the product is still high. And then like cybersecurity or something. So there's lots of different types of software engineering that you could go into. And honestly, being in school and taking lots of different types of CS classes is like a really good way to have an idea of what fields you may or may not be more interested in. Yeah, aside from those things, some other factors to consider are the industry that you want to work in. Maybe you're interested in working for an application-based company like Google. Maybe you're interested in working for a car company or a delivery company or a banking company. Even if you're like the same role, depending on which company or industry you're working for, the type of work that you do can be very different. So that's something to think about. There's also the size of your company. Working for a startup is very different from working for a large corporation. And there's also different types of products. Like even within Google, we have some teams that build user-facing products like YouTube or Google Search or Google Maps. Then we have some teams that work on internal tools. Like we have an internal tool that engineers use to review each other's code. Someone has to build that. So there's a team dedicated to building that. So when you're looking for software engineering jobs, it might be worth thinking about what types of teams you're interested in because it can be very different. Within big companies like Google, it's usually not too hard to switch from one team to another. So that's one advantage. Yeah, that's pretty much all I had to talk about for that section. And the last stuff that I wanted to talk about today is some of my advice for college students such as yourselves, and some things that I did maybe around my second or third year of college that I thought were helpful for me. So I'll try to keep it brief. But the first thing that I really recommend is just building personal projects. And I might be biased because this is kind of how I started CS, if you remember from the very beginning. But I've always had a soft spot just for building personal projects. And having personal projects is very useful because it enables you to build a personal portfolio or resume. So one day, if you're applying for a software engineering job, it'll be very helpful to have a project section on your resume so that you can show the interviewer hey, these are examples of ways that I've applied my computer science knowledge. These are real things that I've built that actually work. And then you have something to talk to them about. Aside from just having stuff for your resume, oh, and on the right here is an example of my resume that's not fully updated. But building personal projects is also a great way to learn new technologies. I think the best way to do it is just figure out something you want to learn or you want to build. Go on Google, search up tutorials for it, and then slowly teach yourself how to do it. I think it's really good to get used to how to self-learn, because once you come into the industry, if you work in software, you probably will have to learn something new when you start a job that you're not familiar with. And one example from my life is I learned C, the programming language, in school. I took one class at UC, learned all about it, and then forgot completely about it, like just because I never used it in school after that. When I started my full-time job about a year ago, my current team uses C++. So when I started the job, they were like, oh yeah, just like take a week or two, learn C++ real quick, and then you can like start coding with us. So I had to go back to my notes from college and relearn like pointers, references. I forgot all of that stuff. But being able to like teach yourself these things is going to be very important in the workplace. And my last bit of advice for you is just to make sure to have strong fundamentals, which I'm sure many of you guys are developing just by taking classes in college right now. Not all the classes you use in college will be used by you in the future, but some of the fundamental courses, like data structures especially, will be applied no matter what subfield within software engineering you go into. For data structures specifically, at least from my experience, most of the questions you get asked for technical job interviews are related to data structures. So by the time you finish taking your data structures class, you technically have enough knowledge to pass job interviews. You probably need to practice a little, but that's the main stuff that companies interview you on. So it's really important to have those fundamentals down. And the other thing is just once you're familiar with a couple languages and this general knowledge, it's very easy to pick up new languages and topics in the future when you need to. You'll become a faster and faster learner with these things. So focus on just developing those fundamentals. And with that, that's all I had to talk with you guys about today. So thank you so much for listening. Hopefully that was useful. Let me stop sharing my screen, turn my camera back on.
Wow. Wow.
Awesome. So yeah, I am open to any questions that anyone might have now.
Great. I guess you said it all. You can hear me on the Telegram channel. Pretty sure you can also ask the question.
Hello.
So we'll take it one at a time. I don't want to go to route you through sadness because I think I have a capacity of 350. Somebody's microphone is very.
Yeah, sorry, Mark. I couldn't quite hear what you were saying.
Yes. So you notice we have about 300, almost 350 participants on Teams. I think that's my capacity. But my class
there
is
were like
actually
100.
yes, the class is actually larger than that. So I extended. We have about extra 51 participants on a private Telegram channel I created for the class. I found a way to route it, and I'm pretty sure they can hear us, and I'm sure they can also talk back and ask their questions. So at this point, I'm not going to waste too much time. The floor is open. Please don't just unmute yourself and speak. I would prefer if you raise your hand, and then I will call you out, and then you ask any question that you have for him. Okay, so I see a hand up. Keep your hands up, whether you are on Telegram or you are on the main Teams page. Okay, so let's do it that way so that it makes it a bit easier for me, and we can sanitize the conversation. Everybody will have a say. Okay, so when I call out your name, please respond, and then let's proceed. Ameni Raphael Kwame Apia, you have a question? Please, the moment you finish speaking, lower your hand and mute yourself again. All right. Let's begin with Raphael Ameni.
Hello, sir.
Yes, we can hear you. Kindly speak up. Yes, I can hear you. I guess Kenny can also hear.
Hello, Kenny.
Hello.
So I want.
We can hear you. Proceed.
I want to know the stack you use for for coding the YouTube ads, or maybe the stack you use maybe probably at Google. And
The
lastly,
stack.
maybe your stack of languages, or and probably your annual salary, or maybe your monthly salary at Google.
Sorry, what was that last part? I heard the part about the stack.
The last part of the question, I'm going to overrule. Allow me to overrule. He wished to know the salary range for a Google software engineer. I think at this point, I would want you to take more interest in working for a giant like YouTube. You imagine someone who just has a channel on YouTube earning over $5,000 every month for ads running on his channel. And imagine how much an engineer probably is earning for putting that solution out there. That should give you an idea how much you should look out for if you land a job. So I'll overrule that particular question. But the first question had to do with the stack of languages you use to develop your solutions, I think. Ameni, can you confirm that?
Yes, sir.
All right, Kenny, I think you can go ahead and respond. Please lower your hand, Raphael.
Yeah, so right now I'm working on the YouTube ads infrastructure team. So a lot of the backend code,
okay.
Let's see, pretty much everything I write right now is C++, and that's about it. Previously, a lot of the YouTube infrastructure was written in Python, but I think we prefer having backend stuff in C++, so we're actually migrating from Python to C++. That's pretty much most of the code that I write. And then there's some like Google specific like internal languages that we use. When I was on Google Ads as an intern working on front end teams, I used JavaScript. Well, I actually used Dart. I don't know if you guys are familiar with that. It's like a framework that Google developed for front end development. So I used Dart and Java. And prior to that, I worked on a different front end team, also within Google Ads. I used Angular and Java. So yeah, the stack that you work on within Google will vary a lot depending on what team you're working at.
Great, great. I think that is actually quite common here as well. Even though we do not introduce our students to it, I know a significant number of them who are already familiar with it. Great. I guess we've answered his question. Theodore, is it Mawuli Biako? Yes. Theodore, you can ask your question. Please, you get to ask a question once. So I'm taking notice of those who have already raised their hand. Theodore, unmute and please ask your question. Is Theodore having any challenge? Okay, I think we're going to... Theodore? Okay, I think we are going to skip you. If you have any challenge and you've raised your hand, you can actually type your question. So we'll skip to Joshua Kanga. Joshua, please take over.
Okay, so my question is about how is the transition from school to the software engineering industry like? So you mentioned before, as a student, like you just wrote code, which basically just worked. But like when you made the transition to industry, you actually had to learn a lot of practices and, you know, how to write good and maintainable code. So like, I just want to know how that process is and how it actually impacts you as a software engineer overall.
Yeah, that's a really good question because that's something I'm still transitioning even after I've been working a year. There's just so much to learn. But yeah, I think when I came into Google following graduation, everyone expects new engineers to take a little while to transition because there's just so many tools we have to learn. We have to learn like how to write tests, how to run experiments, how to write design documents. There's so much we have to learn. So usually what they'll do is they'll assign, like my team manager will assign like a smaller project for me as my first project, and then they'll be very helpful for that first project. And then with each project you do, they'll kind of be less and less hands-on. But when I joined the team, my manager was pretty much fully expecting me to take half a year to a year to like fully ramp up with the team, just because there's so much you need to learn. So I think it's very normal for new software engineers to take that amount of time to like get familiar with working. Yeah, sorry, did that answer your question?
Yeah, yes, it did. Thank you very much.
Okay, no worries.
Excellent. All right, Ebenezer, your turn.
Hello.
Hello.
Ebenezer, yes, we can hear you.
So with the coding side, you said it should be quick and easy when the design is done, when I finish with the design. So my question is, do you go into details like writing the feature logic in the design phase, or it's just a high-level overview of the feature?
Usually we'll get into pretty detailed discussions. Like at the beginning, maybe we'll come up with just a high-level overview, like where should the code go? How should we organize the code? But then we might get into pretty detailed discussion about like what libraries we'll have to use, like how we might want to structure the code. But the part that we don't like, I think design gets into every detail short of actually writing the code itself. So I won't really talk to my manager about like, here's the like exact function I want to write in every line of code inside of it. But it does get pretty detailed just because like the more detail you get into during this phase, the less you have to think when you write code. So it's usually better to have more detail during this phase. And people don't really mind if you include too much details. Like there's no such thing.
Okay. Thank you.
Yeah.
Great. Reynard, your turn. You are up.
Yeah, my question is, almost all tech companies nowadays will interview you based on your algorithms and data structures strength.
Yes.
So my question is, should you focus more on solving algorithms and data structures problems, or should you focus on projects?
What was that last part? Should we focus on algorithms or data structures as opposed to
projects, like personal
projects? Got it. That's a tough question. I can definitely talk about the specific interview process in more detail. Or I don't know if we have time today, but could always do that in the future. But I think both are pretty important for getting a software engineering job. Projects are important because usually on your resume, most of your resume will be work experience. The problem is that as a student, and I experienced this too, you usually don't have too much work experience. It's like, how do I get a job if I haven't had a job before? But like, I need a job to get a job. The best way to do that is to have projects on your resume that basically does the same purpose, because it shows to the recruiter, hey, I built these things using my knowledge. So that's why you would need projects. But that being said, you don't need like 20 projects. If you have like maybe 2 or 3 on your resume, just a handful, that should probably be enough. But yeah, I think projects are important, because if you don't have anything on your resume, you probably won't get an interview from a lot of companies, as sad as that sounds. But data structures and algorithms are definitely like the main part of what you'll be interviewed on. Like all the questions that they ask you will pretty much be, here's like a data structures problem, solve it and talk me through the process. So I guess to summarize, you kind of need projects to get the interview in the first place. But once you have the interview, it's going to pretty much come down to your data structures and knowledge. So I think what I did in college is I spent time working on a couple projects, and then once I had a few solid ones, I kind of put that on pause and then focused the rest of my time, most of my time, on studying for these interviews.
Great, excellent. You indicated your ID. This candidate who has raised his hand, I specifically asked you to add your name, but you can proceed anyways. I'll download the attendance 107155515. You're not expecting me to memorize your names for over almost 500 of you. Okay, so proceed to ask your question. What's your name?
Okay. Derek Tosu.
Derek, okay. Proceed to ask it.
Yeah, so I wanted to ask, on my resume, I know HTML, CSS, JavaScript, React, and on the back end side, I'm familiar with Node.js. To apply to Google, can I apply for the front end and back end position at the same time, or I'm just supposed to stick to one?
Good question. When you apply, usually you will just apply to like a software engineering position. Like when I applied, the role that I applied for was literally software engineer, no specification besides that. After you apply as a software engineer, I think all the interviews are the same, whether you do front end or back end. And then after that, if you make it through, then they'll kind of look at your interests, and then you can specify like, oh, I'd prefer to be on a front end team. I prefer to be on a back end team. And then they will pair you through a team matching process. Kind of funny. I mean, as I mentioned, I interned twice at Google. I did front end both summers. So when I came back, I was like, I should probably do front end since that's what I'm familiar with. And then they put me on a back end team, which has been really good for me because I learned a lot. But as a software engineer at Google, at least, it's kind of a flexible role, so you can kind of switch around, go back and forth. So yeah, I would just apply for that generally. I know at other companies you might have to pick between the two, but I'm not as familiar with that.
Oh, okay. Thank you.
Yeah.
Great. Right. Divine, you are next. You're up.
Okay, so thank you. My question is that you said you had a problem with the button being too small and how to send it back to the design team. I wanted to ask whether it's possible that you could just fix it yourself with some small padding or something instead of sending it back to the team and having to go through the whole process again.
Yeah, that's what I thought. Like when I saw the issue with the button, like with the button size being too small and having to resize it to slightly bigger, in my mind, I was like, it's such an easy fix. Like, let me just change it. It's like one line of code. But like anytime you submit code at Google, someone on your team has to review your code in order for it to go through. So I had to send that code to my manager to review. And then she was like, okay, in order for you to submit this code, you should probably put it through an experiment just to make sure that it doesn't have any unintended side effects. Like what if by making it bigger, something breaks or users don't interact with it as well? Like you never really know. I think that example is a little silly, but there are other cases where if you make a small change within the system, you have to run an experiment just to verify that the behavior doesn't get affected. Just because there's so much, the scale of YouTube is so big, there's so many users, so much money moving around. A small change and a small error could have really big consequences. So better to be safe than sorry. But I generally agree with what you're saying.
Okay, thank you.
Great. Bernard, appeal to Bernard.
Data structures on the very project you working on.
I think your line is not clear, Bernard. Can you take your question again?
My question is on data structures.
Sure.
Did you consider the use of data structures on the very project you're working on?
That's a good question. I feel like data structures actually don't come up as much in work as you might think. Yeah, just because I feel like at least at a big company like Google, so many like, how do I say this? There's so many libraries all written to do things and to do things efficiently that usually when I have to write a function to do something, instead of like creating a new data structure and like figuring out how to do everything, there's usually some library function that already exists and I just call that library function. And I think that tends to be the case at big companies where there's so much like groundwork already written. So I guess short answer is I actually don't use data structures too much at work. Yeah.
Okay.
I think, sorry, just to add on that real quick, I think the one thing that I have to consider sometimes is how to design new classes and like structures, like how to represent data, but not so much like data structures in the sense of like hash maps, trees. Like I've never seen a tree at work ever. So yeah, I think object-oriented programming definitely comes in handy at work.
Okay. Elvis Kakari. Elvis, can you proceed to ask your question? Unmute yourself and ask your question. Elvis?
My question is, we all have challenges, and how were you able to manage to solve your problems, and how were some of your problems that you faced when you were back in school?
When I was back in school?
Yes, please.
So the question, do you have any specific like problems you would want me to talk about?
Okay, through your schooling, maybe you have problems in maybe coding and those stuff, and how were you able to manage learning your courses and everything? How were you able to succeed as a student?
Like as in how to balance my time between like school and like projects or interviewing and stuff like that?
Yes, please.
Yeah, that's definitely tough. I feel like balancing schoolwork with like interviewing and like working on projects is pretty difficult. And I mean, I feel like there's no good answer to that besides like time management. But for prepping for interviews and projects, at least, I tried to make use of like summers. I think summer is a good time to like start practicing interview stuff. Even if you start now, it's not too late, because I think the recruitment process for software engineering usually starts in like September, October. So I definitely always try to do some of that stuff before the semester starts, because I have a lot more time over the summer than when I'm doing classes. During the school year, I think what I'll usually do is like, if I'm working on a project, I'll try to just treat that as like a separate course and try to set aside time for that. Like maybe just set aside 3-4 hours each Friday to work on projects a little bit. And obviously, like if you have midterms or finals or exams, maybe you have to cut down on that. But in general, I think it's helpful to set a certain amount of time to like just allocate it to do certain things. Like when I was prepping for my interviews, which I had to do during school, I would maybe just focus on trying to do 1 or 2 practice problems, maybe every other day. And sometimes I'd be too busy, but having a manageable schedule like that helped me a lot.
Okay, Prince, you are up. Let's make this quick. I think Papaya, you'll be the last person on the list. Prince, proceed.
I want to know your greatest challenge in your career as a software engineer.
My greatest challenge.
Yes, please.
Let me think about that.
Interesting. Yeah. Kenny, if I may ask, how many years have you been in a professional setting?
Yeah, so I previously interned back in college for 2 summers, but since graduating, I've been working here for like a little over 1 year. So still pretty fresh out of college.
Great. That's good to know. I wanted that to come out clear for them to know. Okay, so Daniel, Prince, can you lower your hand, please? Daniel, you are up.
Oh,
Daniel,
I think I still have to answer the previous question. I was still thinking about it. Yeah. So I think my biggest challenge as a software engineer so far has just been like, there's so many things I need to learn. Like within Google, every tool that Google uses is like custom built, like only exists within Google. Sometimes a lot of people joke that if you work at Google, you are very good at, you learn all the skills needed to work at Google, as in sometimes like at other companies, you may not use these tools because they don't exist. But I think a definitely difficult part has just been as soon as I feel like I've learned how to do something, the next project I work on, I'll have to like work on a different part of the code base or use new tools that I've never used before. Or like, for example, very recently, I ran my first experiment, which I talked about in my presentation. So I had to look at all the metrics and stuff. When I pulled up that metrics dashboard for the first time, all I saw was like 100 different numbers. And I was like, I have no idea what I'm looking at. But I think that's a pretty normal aspect of being a new engineer. The only way to learn these things is to get assigned to projects where you have to be a little uncomfortable and figure these things out. Like that's the only way you learn. If I felt fully comfortable already, I feel like I probably wouldn't be learning as much anymore. That's probably my biggest challenge, but I think in a way it's also a good thing.
Okay, that's fine. Whose hand is up? Daniels, Emmanuel. Yes, Daniels.
Hello, can you hear me?
Yes, we can hear you.
I can hear you.
Okay, please, I have two questions, but I'll do them in the same time, at the same time. So,
Sure.
my first is, does your typing speed actually really matter when you're coding? And if so, how do you improve on it? And also, what kind of mathematics do you use when trying to become a computer scientist?
Got it. So the second part was about what mathematics you need to become a computer scientist. What was the first
Yeah.
part?
Does your typing speed really matter when you're coding? And if so, how do you improve on it?
Does your what matter?
Typing speed, typing speed.
Oh, typing speed.
Yeah.
I have never been asked about my typing speed. No one's ever checked. Yeah, pretty sure that doesn't matter. And I feel like when I'm actually coding, my typing speed's like pretty slow because I'm constantly
Oh.
like looking up stuff, finding out like what libraries I need to use. So I don't think that shouldn't matter. As far as mathematics, that's going to depend on what type of software engineering you do. If you remember that slide I showed about like the different types of software engineering, I've been mostly working on like front end and back end, like application based software engineering. I honestly have not used any math, I think, at least not that I can think of. The only thing I can think of is maybe like discrete math, like Boolean logic, stuff like that. But I think if you're working like data science, you probably will need a lot of like probability and statistics, as well as machine learning. If you're working in game development or graphics, you will need linear algebra because that's all like matrix math. So it really depends on the type of field you go into. Cybersecurity, different type of math. But you can definitely get away with not knowing that much. But really
okay. Okay, thank you.
I know exactly why he asked that question, but I'll reserve my comments for after this session. Yes, Richard Ajimai. Richard, please go ahead and ask your question. I'm giving you the privilege to ask all your questions. Kenny, I hope we're not taking too much of your time.
All good. We can wrap it up maybe at the 10 minutes from now.
Okay, all right.
Have a
So
meeting
guys,
after
let's hasten up with our questions. We've got to get back to work. You can also put out your question in the chat section and I will compile them and pass them on to you, okay? Richard, I think you have finished asking your question. Jefta, you are next.
Hello.
Yes, Richard.
Okay, thank you, sir. All right, so my question is, as computer science is very broad, I would like to know how Ken was able to tell that his story is in the software engineering aspect.
Sorry, could you repeat the question? I didn't quite follow.
Okay, so my question is, as computer science is broad, I would like to know how you're able to tell that software engineering is your passion.
Oh, like how did I know that I wanted to do software engineering?
Yes, please.
To be honest, I've never thought about it too much. At least in high school, at least, I kind of, as I mentioned earlier, I kind of got into coding just because I like building things. And like I was interested in making these projects. So that was never something I like forced myself to do. I just wanted to do it and liked it. And I think there wasn't ever really anything that I enjoyed more, if that makes sense. Yeah, I don't know. This is a tough question. When I got to college, I didn't really think about it. I just thought about like, okay, what are like the different things I could study? And computer science just kind of naturally came to mind because that's kind of the one thing that I was like pretty interested in. I do think when we talk about like passion and stuff, that gets a little, that's like a whole nother conversation. But yeah, I don't know. I would say that I enjoy software engineering. I don't know if I'm like in love with it, super passionate about it, like want to spend every minute of my life doing it. But I enjoy it as a career, and I'm happy with where I am. But yeah, sorry if that's not a very satisfactory answer. It's a tough question.
I can imagine, yeah. Great, but it's a great effort. I hope you've answered his question to an extent. Richard, if you can lower your hand. Jefta, you are up. Jefta, okay, Fridaus, please, if you can unmute. The fastest finger at this point in time. We need to redeem the time. Jefta, I guess you have a problem with your mic. Can you type your question? Fridaus, can you proceed to ask your question, please?
Yeah, good evening, sir.
Good evening.
Yeah, please. My question has to do with how one can manage his time. That is combining academics with this course. Usually, because this is a practically oriented course, and we are also having so much in our curriculum. Sometimes it becomes very difficult for we students, especially we amateurs, to be able to combine gaining industrial skills and also combining that with our academic work. So how can one handle both so that you can be great in future?
Yeah, that's a good question.
Okay. I was wondering whether he was directing the question to me or he was directing it towards you, but I think you give it a shot, please.
Sure. Yeah. So I guess this is another question about balancing school with like I guess building projects, developing interview skills for industry. I mentioned before that it's good to like allocate time to like do certain things, but I think one thing I also wanted to mention is that when it comes to working on projects, you also don't have to if you don't have time, you don't necessarily have to work on separate projects. Like if you take classes in school, a lot of times, at least for some of the higher level classes, like maybe not data structures, but maybe if you take like higher level classes, there are projects in those classes, and you'll have a good amount of freedom and creativity on those projects. Like for example, in my machine learning class, our final project was just to take some data set and perform some analysis on it. A little more detail, but it's pretty vague. Those are perfectly fair game as projects to put on your resume. If it's like a fairly open-ended project that you've built for a class, if you do a good job on it, it's perfectly fine to put that on your resume as well. So that might be a good way to save yourself some time and encourage you to work harder on this course or this project, because it's not only useful for your class, but you can also use it in your career or your resume. So that's a good way to like do two things at once. As far as studying for interviews, I don't think there's any way really around that. Like, it's kind of annoying. I feel like the way interview questions are structured are very specific, so you do need to practice them. But usually, I don't think you need to spend too much time on it. And if you have time over like breaks or over the summer, that's a good time to like focus on those things. Yeah, hopefully that makes sense.
So I think Fridaus, the little bit I'll add here is I think he's overwhelmed by the practical nature of this particular course running this particular semester, and judging from his background, catching up on the skills programming skills and background in the earlier semesters, it seems he has not settled in too well, and he feels overwhelmed with the demands of the course and the way it's being structured, and as he has to also fulfill other requirements in other subjects to complete the semester. But I think I've been in that position before. The only advice I would give you is you may have to go the extra mile and put in a little more effort than your counterparts. I had a similar experience during my graduate studies, and the only solution I found around was to go the extra mile because my colleagues had a better exposure and experience than I had during my during the undergraduate days, and I had no other option to complain but to take matters into my own hands and do the needful. And so you have to motivate yourself, inspire yourself. You may have to go the extra mile at this because you can't type 60 words per minute overnight. You probably have to be coding and typing consistently for some time. I always say that you have to get to the point where your fundamentals of programming become second to nature to you. You rather focus more on the problem, and applying the language and the structures is just something else. You just pick and just apply. But if you are now going to trying to figure out what control structure approach, how am I going to get this thing done? My typing speed is barely average. You are even under 30 words per minute. If that becomes another trouble for you, then your career as a software engineer may take a bit of a delay before you hit the top. But I'll encourage you to just push yourself extra hard. I can assure you can catch up with your colleagues and your peers before you graduate. Okay, so we have less than 4 minutes on the clock. It's even less than that. And I still see so many hands. I'm going to give privilege to the few ladies whose hands are up. The rest of you, I'll suggest you type your questions. If we can take them once, then we address all of them at once. So we want to hear some female voices. I can see Priscilla. Please ask your question. We'll take just about the 3 ladies whose hands are up, and the rest of you guys kindly type your question in the chat section, please, for me. And then I don't want anybody's question to be left hanging, So please cooperate with me on this one. So Priscilla, please ask your question.
Hello.
Yes, we can hear you. Just speak up a bit.
Okay. So please, I want to ask the current evolution in technology. I want to know how it keeps up with the current trends and advances in the field.
Okay, you want to know how it keeps up with current trends. As indicated, almost everything in Google is something new you have to catch up on. So, Kenny, how do you keep up with latest trends in technology?
What do you mean by latest trends? Do you mean like what companies in the industry are doing, or like what technologies are coming out, like what coding languages people are using,
exactly.
What you need to learn?
Coding approaches to solving the problem. New ones popping up every day.
Got it. I guess if you're talking about like frameworks and languages, since there's like new ones coming up all the time, I personally wouldn't worry too much about keeping up with those. At least for big companies like Google. Well, first of all, it's such a big company that will take them a very long time to switch to using a new language, so don't worry about it. But a lot of companies just want you to have very strong fundamentals. Like in my case, I came in and they were like, okay, our team uses C++. We'll just learn it now. They expect that if you have strong fundamentals, it should be easy for you to like quickly pick up another language if you need to. So definitely focus on developing those fundamentals, and don't worry about learning like the new languages. Like I honestly don't even keep up with them, but I know that one day if I need to do it, like if I need to learn them, I can.
Great, excellent response. In fact, that's all we've been trying to make them understand. Your fundamentals. If you miss out your level 100 and programming 1, there's no guarantee. You have to just grasp the fundamentals, and the rest is application. I mean, I don't know how best we can explain this. Get the logic right, and all you need to know is a syntax. The concepts are pretty much the same. Functions, classes, they don't change.
Yeah. I think I definitely took me a while to realize, but after you take enough courses, you just start to realize like, hey, like picking up these things, like picking up the language itself is like the easy part, but that just comes with time. So don't force it too hard, I guess. Don't worry about it.
Yes. Okay. So we'll take the last question, and I would want my head of department to put in just one last word before we sign off. So which other lady is online? Dorcas. Yes, you are our last lady. The rest of the guys, I'm sorry, I'm not going to call you. Dorcas, please ask your question. Unmute yourself and ask your question.
Hi.
Yes, Dorcas, we like how audible you sound. Yes.
Yes.
Please.
Yes, please, can you hear me?
Yes, we can.
Yes.
Okay. So Kenny earlier mentioned that in school you are given tests and exams and you're supposed to work within a specific timeline. But then in the real world, that's not how it is. And you have to also work with people. And I know how working with people can sometimes be, because sometimes the way you think things should be is not how somebody thinks it's supposed to be. So it's going to take quite a long time to get a project done. So I want to know averagely, what are the timelines that you are able to use to work on a project? Yeah, thank you.
Yeah, that's a good question. That really depends team to team. Some teams have like very tight deadlines. Some teams are more loose. Just depends what your team is doing. My team specifically, or I guess in Google in general, we usually set project goals for ourselves every quarter. So 4 times a year, or like 1/4 of the year, we'll set like our own goals, or our manager will help us set goals. Be like, our goal this quarter is to be 50% done with this project, 25% done with this project. And these are all like pretty, on my team at least, I feel like the deadlines are not super strict. So a lot of times we won't necessarily meet them, or we'll finish some things but not finish other things. And then we just carry over projects from one quarter to the next. So it really depends. I know like my team is working on ads, obviously. So I feel like the deadlines are not as pressing, because a lot of times we're just introducing new ad formats that don't exist already. So it's like, if the ad's not there, no one's going to suffer. It'll just be better when we have it, from a company perspective. But I have a friend who's working at Apple, and for the recent like iOS, iOS 15 launch update, his team's been super busy because they've been trying to like just hit deadlines because they have a launch coming up. So it really depends like what company you're working for, what team you're on. But from my experience at Google, at least within ads, I'd say that the deadlines are pretty relaxed and like manageable for the most part.
Thank you, Kenny. I think it's been a good 1 hour, 40 minutes well spent having you as our first guest for this first session of the mentors virtual mentor engagement. We are really grateful. I think I will let my head of department have the last word, but before he does, there's a question I was expecting at least one person to ask, which they haven't. How do you get to intern with Google? As a college student?
Yeah, it's pretty much the same process as applying for a job. And I actually don't know how it works for like non-US roles. Like, I don't know if there's like a separate process for international applications, but within the US at least, when we're in college, we can apply to a special, like on the job application page for Google, there'll be a software engineering intern application. You just apply to that usually in your 2nd or 3rd year of college. They usually don't take 1st-year students, or there's a separate like intro program for that. You just apply to that as you would a normal job, send in your resume, and then they interview you just like they would for a normal job. But the interviews are usually a little easier for interns than like full-time engineers. They're also a little shorter. For my intern interviews, I think I had to do 2 like technical interviews. For full-time, I think it's like 4 or 5 back-to-back, which is exhausting. But it's really not that different from applying for a regular job. Yeah.
Great. Thank you very much for the response. I would want my head of department to put in a few words to appreciate your kind gesture. HOD, this is Dr. Jamal Dean Abdullahi, my head of department of the Computer Science Department, University of Ghana. Yes, sir.
Hey, thank you, Mark, for your introduction. I was trying to just hide among the students throughout the session, but I got overwhelmed and I enjoyed the talk. I said, Mark should give me an opportunity to say thank you to Kenny. I really appreciate the presentation. At least having spare your 2 hours of the night to engage with us and the students has been great. And I noticed that some of the students asked beautiful questions. And I think I want to say that we have enjoyed you. And then we hope that you have enjoyed us too. And that you will open more opportunities. I'm sure you have colleagues, software engineers, and also colleagues who are in other domains of computer science that may be willing to talk to share their experiences with the students. So I hope it will not end with you. You'll be able to get us some of your colleagues so that in the future we can engage them to also talk to our students.
Great.
Yeah, so I think that is, that's what I have to say. But I just want to ask one question that is bothering me. Sure. I know C++ is a very, very old language. One of the languages I started programming when I was a student. I don't know why YouTube chooses to use C++ when we have other languages, C#, Java, and all those new languages that are coming up. Why are they sticking with C++? There must be something interesting there.
Yeah, I think, I don't fully know myself because I'm not the one making these decisions, but I think we prefer C++ to like Python and Java just because for like backend and infrastructure, I think it is more efficient, like smaller compile size. Yeah, and I think the other thing is they have to choose a language that's old enough that enough engineers know it. Like if they choose a really new language, it might be just a lot of work for everyone to learn everything. But yeah, elsewhere within Google, we do use Python, and I use Java on my previous teams within Google. So it really varies like from team to team. Yeah.
All right. Thank you. And thank you so much for the night.
Yeah, thank you for having me. I really enjoyed speaking to all of you today. It's probably the largest group of people I've ever spoken to in my life. Well, amazing experience.
Great.
And yeah, thank you to the students for just asking very thoughtful questions. And I'm sure Mark and I will talk again in the future.
Most definitely. Yes, it's not going to end here. My special secret activity for all students and participants is you will have just about 10 minutes to complete a form I have just shared with you in the chat. For those of you on the Telegram, you will see the link right there. You have just 10 minutes to complete it. You'll be required to use your student email accounts. This is very, very important. It adds up to the 10% bonus on the continuing assessment. Within the next 10 minutes, you won't be able to access this form. And so the clock starts ticking right now. It's 9:40 here, 9:40 p.m., 21:40 GMT. I'm guessing that is about 2:40 p.m. at tennis and midday. Yeah. So please get to it and then complete this form for me as quickly as you can. Kenny, on my behalf and on behalf of my students and of course my department, my head of department, the entire faculty of Department of Computer Science, University of Ghana, thank you very much for accepting this invitation and spending quality nearly 2 hours with us. We shall continue this conversation definitely beyond this platform, and I'm looking forward to engage with you once again.
Sounds good. Thank you so much.
Great. Right. Okay, guys. I'm ending. So Kenny can leave us right now. We won't hold him too much. I'm going to keep this platform open for just about 4 minutes. In case you need to pick the link, the clock is ticking. At 9:45, I will end this session. You can still continue with the link. Kindly complete it for me. It's available. Others are completing it. If you use your personal Gmail account, you cannot access the form. I repeat, if you use your personal Gmail account, you can't access the form. You are required to use your student email, the one that ends with the domain st.ug.edu.dh. If you are signed in with your personal Gmail, whatever, it won't work. I need to be sure that you are using your official account. Stop sending me, you need permission. I said use your Gmail, your student email.
So please, the chat is not available here.
What is not available where?
The chat.
It's not available on Telegram.
No, here.
Here?
Yeah.
You can't see the chat.
Yes, please.
I'm looking at the chat. I'll put the link in there. Why can't you see the chat? What is your problem?
There's no message. It's not activated.
Chat on Microsoft Teams.
There is no chat activated on Microsoft Teams for you.
Yes, sir.
Okay.
Meeting sections. Everybody is supposed to have access to the chat section.
No, it's been disabled.
So we don't have it.
That is strange. So whatever I have typed, you can't see.
No.
Yeah, we can't see anything.
How is that possible? How is that possible? I see. That's quite strange to me. I can see conversation. I have not disabled anything. This is unfortunate for you guys. So how do I send it to you? It's supposed to be possible. You're supposed to see the chat. How many of you can't see the chat? Is there anybody here who is able to access the chat? Kindly confirm. Anybody who is able to see the chat? Meeting chat. Nobody is seeing the meeting chat.
No, sir.
So please, I think you can send it to the course reps so they send it to our groups.
No, I'm not sending it to course reps. I'm sending it to your announcement right now. Check your emails. I'm sending it to your emails right now, your student emails. I'll give you an extra 4 minutes. Please make sure you complete it for me. I've sent you the emails. All right, thank you very much, everyone. Let's psych ourselves up for the next mentor session. We have interesting guests coming up, so I look forward to seeing you. Please do your best to meet all deadlines required, and we should be fine. All right, so have a good night, and see you on the flip side.
Thank you very much.